Hello, this is going to be another project showcase. This one over a scalable neural network that I coded from scratch using the math and the NumPy packages only. It can be used for any problem. It's just a regular old like feed-forward network. And here it is. This was a unique challenge for me because unlike a lot of my other stuff, this one there's no like visual element. It's not like very flashy. And it's a lot more a math challenge than it was a programming challenge. And in fact, I'm not very proud of this programming at all. This is one of the older ones I've shown. I finished this May of this year, 2022, I think. Actually, wait. Oh no, May of 2021. Oh yeah, no, it's not even May yet. Yeah, May of 2021. So about a year ago almost. And here it is. You can change the activation for each hidden node. You can change the output activation with this. I made a couple modifications to this since I made it. One was that I changed all the leaky ReLU activations, which is what I had originally, which is this, to sigmoid, because I was having vanishing gradient every single time. And I changed the way that a correct guess was calculated. So like before, it was considered a correct answer if the cost was lower than 0.01. But I've learned a lot about deep learning since then. And I know that it's a little more typical to use argmax and just see if like the argmax is the correct answer. So that's what I've changed it to. But yeah, here it is. Here's feeding information through the network to get a cost and a bunch of like the values of every node. And then here's back propagation. It's not really practical to explain how it works. And since I coded about a year ago and I didn't comment it like at all, I can see how it works based on the variable names, but it's not something I can like explain in a video. But yeah, here it is. It's just a bunch of crazy matrix math. If you want to know how these things work, it's really fascinating. This is definitely like this has like a neural network specifically have filled me with more wonder than like any other topic in programming. It's really amazing to me how something can like detect and apply patterns in an algorithmic way. It seems like such a uniquely biologic, like organic thing to do to be able to do that. But we can make computers do it, and I found that super fascinating. So this is, before I had ever even tried using anything like TensorFlow or anything like that, this was my first project with neural networks, just learning the math and doing it from scratch. My first attempt with this was probably about a year before I actually made this one, and I approached it more as a programming challenge then. I tried to find code for it and then understand what the code was doing. That ended up being a bad approach. I tried again in early 2021. I tried the approach of learning all the math and then programming it, and that ended up working out much better. It was a lot of fun. And yeah, here it is. I've got a few sample problems to look at. So here's like a point classifier where we're supposed to classify whether a point is above or below a line. In this case, the line is 1/4 x squared minus 3. And the numbers range from negative 20 to 20, I think is what, yeah. That's the value, like the x and y values range on those. So let's just run it. So yeah, there it goes. It's training, and okay, it immediately reached 90% accurate, which is good. It doesn't really show progression very well. If I can try this one more time and get a slower one to start. Okay, yeah, we started at 84 because I want you to be able to see it kind of growing and climbing up. Yeah, there it goes. I think I have a breakpoint. Yeah, 95. So once it hits 95%, if it does at all, because it seems to have reached a minimum. But if it ever hits 95, it'll stop. But yeah, there you go. It's about 95% accurate at determining whether a point is above or below 1/4 x squared minus 3. So there's that one. Oh wait, it's about to hit it. Oh come on! Oh my god! There we go. Okay, it made it to 95% accurate. Fantastic. This one is the classic like iris problem. Don't mind the code. It's not very good. I know more now than I did then. So let's run this. This one, each epoch goes pretty fast. I don't know how you pronounce that. But you can actually see the learning progression. 60, 63, 67. Now it's hitting 70. Oh, it went back down. Now it's at 66 again. Oh, there we go. It's hitting lower 70s. Okay, we're hitting 80s. Saw 90 for a second. 93. Come on. I don't know if it'll... Oh, there we go. We got 96. Yeah, there's in just 580 epochs. Yeah, this was so early. Like, at this point, when I had made this, all that I knew about neural networks was the math. Like, I didn't know any of like industry standard like terminology. I mean, I knew a little bit from like the papers I read, but yeah, I mean, I know, yeah, it's very cool. And then here is a handwritten digit classifier. It classifies MNIST digits. This one takes a long time to train. So I'm actually going to pause the video and leave it going for a while. I'll let you see just how long it takes right now. Oh, it's actually going to take a while to load the stuff too. But yeah, I mean, as you can see, all that I change in these is I change the number of hidden layers, number of neurons per hidden layer. Oh, and by the way, this is scalable, but like the hidden layers is always a rectangle, if that makes sense. So like you can specify the number of layers and the number of nodes for each hidden layer. You can't really vary the size other than that. But you know, this does let you increase the complexity enough, I think. So yeah, 2 hidden layers, 20 nodes per layer, doing the MNIST thing. This works for me. And I mean, yeah, the code, this part is the same on each of these. It's applicable to any situation. You just change the data. It does all the rest for you. I'm pretty proud of this. Not for the programming like I am for a lot of my other projects, but for the math. I just think that like this was a whole lot of trial and error and solving a lot of weird math problems, but it was a very fulfilling project. I enjoyed it a lot. So yeah, you can see how slow this is. It's not nearly as optimized as something like anything you use in TensorFlow or Keras. And it is stochastic. So like there's no like, you know, there's no momentum and there's no batch sizes. This updates the weights every single training point, I guess you could say. But yeah, it's 20% done with this epoch, and it takes quite a few to even get to a high accuracy. I think once I saw it get up to like 95. I think that's the highest I've seen it. And mind you, that was with this cost or this correctness measurement, which is not very generous. So yeah, I'll pause the video. I'll be back in a while. Okay, this one has been running for quite a while now. It's about 10 o'clock at night. I started this several hours ago and forgot about it. So it's on 24 iterations. And as you can see here, it has progressively gotten better. So on the first epoch, it was at 60%, and it kind of gradually climbed up, and then kind of hit a little bit of a plateau around the upper 80s, early 90s, and is still progressing lightly, but not a whole lot. And yeah, we're just about to see the ending of the 25th. Maybe. There we go. Okay, we got up to 91.39% accurate, which I think is pretty dang good for this highly unoptimized, you know, kind of basic feed-forward neural network. But yeah, I hope you guys enjoyed this video. My next video should be the tutorial on the tweet LSTM, which I'm excited for. I'm working on it right now. I figured I should get this one out first because it would be easier. Yeah, I hope you enjoyed it and have a good one.